Hello everyone. The branch and bound technique is one of the approach to find out the optimal solution. Why do we need a branch and bound approach than already existing algorithms? So here depth first search, breadth first search, hill climbing algorithms and best first searching algorithms are used to solve few of searching problems by finding the feasible solution. However, these searching algorithms cannot be used to solve the optimization problems by finding a optimal solution. So, to find out the optimized solution, we have to go for branch and bound technique without an exhaustive search in the sense trying with all possible solutions. So without trying with all possible solutions, we can find out the optimal solution within average time complexity. This algorithm is using the state space tree, which is having a set of vertices and edges. So here it is used to find out the optimal solution with average case time complexity. So here, before enumerating the candidate solutions of any branch, the branch will be checked against two bounding functions. So either one is upper bound value or lower bound value to find out the optimal solution. If any vertex which is not provide you the optimal solution, then we have to remove that path. Suppose if this vertex is not giving you the solution, optimal solution, then we have to discard this path. So by discarding this path, we can move to another path, right? There is the possibility of optimal solution. Here the branch and bound is having two mechanisms, which it will generate the branches whenever searching is starts for finding the optimal solution from the solution space. For example, if you start from the root vertex, then it will generate the branches to find out the path for finding the best optimal solution. Like that, it will generate a bounding function. That means we have to calculate the lower bound value or upper bound value to find out the criteria, that means bounding for this particular vertex. So if bounding function is not satisfied, then we have to terminate that path by from that branch. The branch and bound algorithm is using breadth first searching with the pruning. That means we have to estimate that all the possibilities from that each and every vertex. So in the breadth first manner, it is very efficient algorithm with average case time complexity, because if there is no possibility for the solution, we will terminate that path in the earlier stage itself. That's why it is provide you the optimal solution with average case time complexity. But the worst case time complexity is exponential. That is, your solution may be available in the 2 power n, or depends upon the problem statement, this base value will be changed. There is three different methods available in the branch and bound. We can use queue based branch and bound approach, which is using the first in first out approach, and another one is stack based branch and bound approach, which is using last in first out or first in last out, and third one approach, recent approach, advanced approach, is the least cost based branch and bound approach. Here the generic algorithm in the branch and bound is here we will use the bounding function for each and every vertex to compute the lower bounds of nodes for in the given search space tree. Suppose when you are having the search space tree like this, we have to calculate the lower bound for each and every vertex. Then we have to find the solution for the given problem statement. Here the lower bound value, after calculating the lower bound value, we have to store it in the some variable. So suppose if we don't have any lower bound value, if it is unknown, then we have to initialize with infinity, unknown value. So here, after calculating bounding value, we have to save as the upper bound or lower bound for the candidate solution. Here, if it is queue based or stack based branch and bound, we have to initialize the memory structure, queue structure or stack structure to save the partial solution of each and every path. Here we have to check the queue or stack until it becomes empty. We have to keep on take the node. Suppose if I have the stack, in this stack I will insert initially, this is the starting vertex, I will insert the starting vertex, then I will explore this. After that, after explored, here I have three nodes for example. So these three nodes will be inserted. So now I have to take one by one from the stack or queue, whatever data structure you are using. We have to take a one node at each time. Then if this node provide you the candidate solution, then this will be, if it is less than the bounding function, then which is the best solution as of now. Then if it is best solution, then you store this calculated bounding value into the bounding variable b. Else if it is not provide you the candidate solution, what we have to do, we have to go for new path, new nodes. It will create the new nodes from the new branch. Okay, so that is the thing. So here, for each branch and vertex, so if it is not provided the solution, we have to go for the third one. Okay, that is the thing. So if it is for every node, we have to calculate the bounding lower bound value, and it will be compared with the already existing lower bound value of its parent. So here every node is having, right, if its parent value is greater than this, I mean calculated value is greater than parent bound value, we should not do anything. Otherwise if it is less than, but the calculated value is less than the parent bounding value, we can store that in the store that node inside the queue or stack. So like that we have to keep on do that until finding the best solution by extending the branches and vertices. That means two mechanisms generating the branches and vertices in the branch and bound algorithm. Thanks for watching.